What's that you say? It's a lovely day for factoring? Why, yes, it is a lovely day for factoring, because every day is a lovely day for factoring. So, many of you have asked me the question, how do I know which method to use? You've taught us about the difference of two squares, you've taught us about perfect square trinomials, greatest common factor, Peltier's pans. What do I do? There's too many ways to factor. So, I have come up with this factoring flowchart. And actually, that was a lie. I did not actually come up with this. So, I borrowed it from Miss Peltier, who may have borrowed it from someone else. But it is a flowchart. So it used to be more detailed than this, but I took a few things off because you haven't yet learned about the difference of cubes, etc. So I have shrunk it down. Okay, so, just so you know, there is a PDF version of this saved on my calendar, so you do not have to write all this down. You can just open up the PDF version and follow along. Okay, so the first thing you should always ask yourself, is there a GCF? That's always the first question. So, if there is, yes, factor it out. If there's not, the next question you should ask yourself is how many terms does it have? Does it have 2 terms? If it has 2 terms, I follow over to this path. If it has 2 terms, after I've taken out the GCF, I'm going to check, is it the difference of 2 squares? Because the only thing you've learned to do with 2 terms is check, is it the difference of 2 squares? So, no, stop. That's the end of the story. Yes, use a squared minus b squared equals a plus b, a minus b, and factor the difference of 2 squares. Bam. All right, now let's go back. Does it have only 2 terms? Why, no, it does not. Does it have 3 terms? Why, yes, it does. Okay, is it a perfect square trinomial? Why, yes, it is. Well, then use the perfect square trinomial information that you learned, which can be found at the bottom of your chart. No, it is not. Well then, let's check. Can it be factored? Look for 2 things that multiply to make C, but add to make B. If it has a leading coefficient, use Peltier's pans, but use a method that you've learned to factor a trinomial and factor it. If it cannot be, then maybe it is a prime trinomial and it has no other factors except for 1 and itself. So that is possible. That it's possible that it cannot be factored. Okay, so refer to your PDF as I do some practice problems with you. Let me think. Does it have a greatest common factor? No. If it doesn't have a leading coefficient, or the leading coefficient is 1, it does not have a greatest common factor, so I can skip that. So what should I do next? Does it have only 2 terms? No. Does it have only 3 terms? Yes. Is it a perfect square trinomial? Well, p squared is a perfect square, but 14, that is not a perfect square. Can it be factored? Well, let me check. All right, p and p. So I know that one of these must be a plus and one must be a minus. Since that's a negative sign, I know it needs to multiply to make negative 14. But add to make negative 5, so now I'm going to think about 14, so that's 1 and 14. No, that's not going to work. 2 and 7. Ooh, that might work. 7 and 2. And then I can go back and check my work and make sure that that works, and it does. Okay, so here, we go to this one. Question number 1. Does it have a greatest common factor? Yeah, it does. K. Okay, factor OK. All right. Does it have only 2 terms? Yes, it does. Is it the difference of 2 squares? Well, I factored out a k, and those are not perfect squares. 9 is, but 7k definitely is not. So if it's not, stop. I'm done. All right, let's try some more examples. All right, so step 1. Does it have a greatest common factor? Does it? 6. Okay. All right, I took out the greatest common factor. What is next? Does it have only two terms? Yes, it does. Is it the difference of two squares? Well, I took out the GCF. That's a perfect square. That's a perfect square. There's two terms. There's a subtraction sign. By word it is. So what can I do? Final answer. All right, moving on. I see this. First, what should I do? I still can't remember. Oh yes, does it have a greatest common factor? It does. I can take out a 2. All right. Okay, so I took out a greatest common factor. I'm going to consult my chart. What should I do next? Does it have only 2 terms? No. Does it have only 3 terms? Yes. Is it a perfect square trinomial? Well, I don't know. That's a perfect square. That's a perfect square. So let me check. Alright, so 2x times 2x. And I know that's a negative, so this must be a negative 3 and a negative 3. So 2ab, 2 times 2x, times negative 3, that's 4x. Look at that! It matches. It is a perfect square trinomial, so look what I can do. Alright, so it's a perfect square trinomial, so what can I do? I can do 2x minus 3 squared. Okay, and don't forget that you took out the GCF here, so I have to leave that GCF here, and now I factored this part, so this part right here, I found out that it was a perfect square trinomial, so then I went ahead and wrote 2x minus 3 squared, and I still have the GCF out here. So I am done factoring that. Alright, 2 more examples. Just kidding, I lied. There's only 1 on that board. Alright, so first step, I'm going to ask myself, is there a greatest common factor? So I look, 8, 86, and 60. Those can definitely all be divided by 2. Could they be divided by something bigger? I don't think so. Let's try 2. Alright, so I'm going to try 2, and I also see that I can factor out an x. So that would give me 4x squared plus 43x plus 30. Alright, so I have 4x squared plus 43x plus 30. So, now that I have 3 terms, I ask myself, is this a perfect square trinomial? That's a perfect square, but 30 is not, so that won't work. So now I'm going to see, can I factor this? So, I'm going to use the pants method. So that's going to give me 120. So something that adds to make 43, but multiplies to make 120. So, what about 40 times 3. So 40 times 3. So I'm going to rewrite it. And many of you have been asking, how do I know where the 40 goes and where the 3 goes? And I've been telling you, it doesn't matter. It'll come out the same way. But I'm going to put the 40 with a 4, because then I can factor out a 4. And the 3 with the 30, because I can factor out a 3. Okay, so 4x, and here I'm going to factor out a 3, and then don't forget you took your GCF out in the beginning, and a lot of you forgot that on the last quiz, so put that out there. And that is therefore your final answer. So I hope this video helped you to review of how do I decide which method I should use, and once I use this flowchart, how can I factor?